Hello friends, good morning. Well, nice to say hello to all of you. This was the numerical problem that was put up in the group. So as you can see here, well, I have the circuit that was given, the network that was given, and I have connected a battery here, as you can see, of constant voltage source V, and you can see that this point is taken as reference, and I have just created one more terminal here, A dash and H dash. Okay, I'll tell you why we have connected that, and this is how the network was looking at. Now, as you can see that these two terminals are shorted, so I will get here VA is equal to VA dash is equal to V, VH is equal to VH dash is equal to 0, because it's the reference point. Okay, and accordingly, what I have done here is, this part, I have cut it off. You can see I have cut it here. The circuit I have cut it. Okay, I have just separated A and A dash and H and H dash. You can see, and of course, I have also disconnected this circuit here, and of course, well, I have disconnected here, I have disconnected here, right? And also, all the lower circuits I have disconnected here, this to this, and etc. etc. So you can see that this circuit is equivalent of this. Okay, that means now I have a network ABHC. I have a network ABHC on the top, and the circuit below, the network below is disconnected. That's what you see here. Okay, and I can do this. I can legitimately do this because because we have been asked to find the resultant network. I mean the equivalent resistance between A and H. All right. So here we go. So now, if you look at the network ABHC, it is a Wheatstone network. Okay, and since this resistance and this resistance are equal, okay, and these two are also equal, the potential at B and C will be same. The potential at B and C will be same. If you remember, we used to connect a galvanometer there between B and C, and under balanced condition, no current will flow. Okay, so we get that condition. Now, similarly, if you see here, to this point A and H dash, if we connect the same voltage source here, so the current will flow like this, and then into these two networks. Again, you will find that the potential at D and potential at E will be same, because this resistance is equal to this resistance is equal to this resistance. This is equal to this is equal to this. So DE will also be at the same potential. Okay, I suppose this is understood. Okay, fine. So from here on, so therefore now you see again FDGE. Okay, this is again going to form a Wheatstone bridge with D and E at the same potential. That is, if you connect a galvanometer between D and E, again it will show null diffraction. Okay, so this is how it looks. And now, equivalent of this, I will show you. Equivalent of this will be this thing. As you can see here, in this is the common point A, right? What we have got here. This is B, and this is C. C, B, and this point will become H, as it is. You can see here, between A and B there is R, between A and C there is R, and so on and so forth. And here you can see that, as I told you, B and C are at same potential. It forms a Wheatstone bridge, and therefore I can connect a dummy wire here, zero resistance wire here, or any resistance for that matter, because if I connect a dummy wire there, it will not alter the current or the voltage. The nodal voltage or the nodal current at B and C will not be altered, so I can jolly well make this connection. Okay. Now, similarly, if you look at the network here, this part. Okay, sorry. this part, if you look at it. So here also, sorry. So if you look at this part of the network, so this part of the network is, basically these four resistors. And again here you see this point. So this point will again be, this point is F. Okay, and this point becomes a D, and this point becomes E, and this point of course is G. Right? And again you see D and E will be at same potential. That is, if you look at it as a Wheatstone bridge. Alright, and therefore I can now make a W connection. Right? Okay. And then of course the resistor, that is this resistor is here, and this resistor is here. Okay, so that's how D and D get shorted, B and D get shorted. And of course I have these additional two resistors. These two additional resistors, this resistor and this resistor, okay, they are coming in parallel. Okay, so this is how the network is going to look at. Okay, now we will reduce this network, because now you see this R and R are in parallel, so this will become R by 2, and this R and R are parallel, so the combination of these two will again become R by 2, and R by 2 will come in series. Similarly here, these two parallel R by 2, these two parallel R by 2, R by 2 will come in series, R by 2 will come in series with this R and this R. Okay, and that's how the reduction will take place. Okay? Okay. So that reduced network is this. Okay, that is it. That is, I have converted this network to this. So this is how it gets reduced. Okay, so this gets reduced to, again here this is A and this is H, and this point, as you can see here, what is this point now here? This point is BC combined, and this point is D and D combined. Okay, and these two resistors will come in parallel R by 2. Okay, now again you see that again if you see this potential here is V and this potential here is grounded. So this potential here will be V by 2. Simple voltage divider. And here you see the combination of R and R by 2 will be 3R by 2. Combination of R and R by 2 will again be 3R by 2. And therefore this potential will also be V by 2. So these two are at same potential. So no current will flow in this network, in this resistor. So it's a dummy resistor. Okay, it's a dummy resistor. You just have to knock it off. And then what happens is these two will come in series, R by 2, R by 2. So this will be R, and here R by 2, R by 2, R by 2 will come in series. So that gives rise to 3R. So this will give rise to 3R, and this is R. So you will get that parallel combination. I suppose it is clear. Okay, right. Then thereafterwards, you will find the reduced version of that. Okay, so as I told you, so this is R by 2, R by 2, R by 2, R by 2 will be R, and R by 2, R by 2, R by 2 will be 3R. So R will be in parallel with 3R. So R parallel 3R, again A and H in between that. So that combination will yield this final answer. Sorry. So this is it. So you get here, okay, you will get here 3 by 4, get here 3 by 4 R. So that's the final answer, and R is 10K, so 10K into 3 by 4 will give you 7.5. Okay, that's the simple thing. Anyways, I have tried to explain this. Now, if you still want to, interact with me, you are most welcome. If you are interested, you just put it in the mail that you want to interact. I will send you the link. I have the Zoom connection, so I can send you the link, and we can have live interaction also. Okay. Thanks, friends, for asking it out. and I'm enjoying, I'm enjoying interacting with you. I'm sure you will be hearing me and I'm able to hear you, right? So that's fine. Huh? Thank you so much.